Given a string s, return true if it is a palindrome or false otherwise. A phrase is a palindrome if after converting all uppercase letters into lowercase and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. So under these constraints, all of these are palindromes, but this isn't. Dude is not the same as edud. To make sure the string is the same forwards and backwards, we can just reverse it and see if it's the same as the original. But how do we ignore case and non-alphanumeric characters? Well, the question actually tells us that we can lowercase anything that's uppercase, and then we can just remove the non-alphanumeric characters. And if we do that, we'll be left with what you can think of as a clean string. And once we have that, we can just see if it's the same forwards and backwards. So we'll call our clean string clean s, and then we'll start it as empty. And then I want to look at every character in s, and then if it is alphanumeric, then we want to add it. So if C is alphanumeric, and this is just pseudocode, I'll come back and work out the details in a second. So if it's alphanumeric, then we want to add it to clean s. So clean s plus equal C, and we want to add the lowercase version if possible. And then finally, we just see if clean s is the same forwards and backwards. So we can return clean s and see if it's the same as clean s reversed, which is clean s, : -1. That's just the gross syntax for reversing a string in Python. And then we don't want to forget about this section. And to get this to work, I'm just going to create a set of all the alphanumeric characters. So I'll call it alphanumeric set, and then we'll just have all the letters, lowercase and uppercase, and all the digits. So I just sing the ABCs: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And then you can do the rest for the uppercase letters and the digits. And then finally, you can just see if C is in alphanumeric set, and then we should be done. Now, there are other ways to do this. You can look at the ASCII values for each letter and do some math there, but I think this is actually more straightforward and easier to do. You don't have to remember anything about ASCII values, which are unnatural to work with. And then there's yet another approach. So instead of this line, you could have instead if c.isAlnum, and this built-in method will tell you if C is alphanumeric or not. And we'll try this approach in a later solution. So let's go ahead and submit, and we can see that it works. So my first instinct was that this would run in O of n time, but then I remembered that strings are typically immutable, and there's a relevant section from the Python docs that addresses this. Concatenating immutable sequences always results in a new object. This means that building up a sequence by repeated concatenation will have a quadratic runtime cost in the total sequence length. To get a linear runtime cost, you must switch to one of the alternatives below. So it's quadratic because each time we append a character to clean s, we have to write all the characters into a new string. To illustrate this more concretely, I have an example here. Assume you have a case where s is A, B, C, D, E, F, G. In the first iteration, we'll write one character, A, and then in the next iteration, two characters, A and B, and then 3, A, B, C, and so on until the last iteration where we'll write all of the characters A, B, C, D, E, F, G into a new string. That means on average, the loop will write about n/2 characters each time. And then remember, the loop is going to run n times. So that gives us n times n/2, and that simplifies to O of n squared. O of n squared time isn't great. So I'm wondering, can we do this faster? There are some optimizations within the Python runtime that can sometimes avoid quadratic performance in this case, but they don't always work. And so in the worst case, appending a character to a string is going to take O of n time. But we can append to the end of an array in O of 1 time because arrays are mutable. So that raises another question, which is, can we use an array instead of a string? If we could get that to work, it would guarantee that we would get O of n time overall instead of O of n squared. If we flip back to the docs, they suggest a bunch of ways to avoid quadratic time, and using arrays called lists in Python is the first suggestion, exactly what we just came up with. If concatenating string objects, you can build a list and use string.join at the end. String.join at the end is useful if you need a string at the end, but we actually don't because we're just returning a Boolean. This seems like a promising idea, so let's try using an array. So I have the previous approach as a starting point, and there's actually not a lot we have to change. I'm just going to change this empty string into an empty array, and then the syntax for adding to that array is a little different. clean_s.append c, and then we'll lowercase it if possible, and that takes care of line 8. And then we're actually done. The last line stays exactly the same. Now we can submit, and we see that it works. So this is a lot faster. It'll take O of n time, unlike the previous O of n squared approach. And we can't do better than O of n because we have to examine all the characters at least once. And then for space, it'll also be O of n. That's because in the worst case, we have to copy all the characters in S into our clean S. So we've maxed out what we can do for time, but is it possible to use less space? Let's go back to our examples and see if we can notice anything we missed before. So I have ABBA, and what stands out to me is that the first and the last are the same, the second and the second to last are the same, and so on if we had more characters. And a picture is starting to emerge. We can compare characters one pair at a time from the outside and then going inwards. And if they all match, we have a palindrome. And then of course, we have to ignore non-alphanumeric characters. And so if we get something like this with a hyphen, the picture looks like this. Outside in, we have a match, and then we have to somehow ignore this, compare these, and we still get a match, and we return true. And then if we had ABBA with an S, the first pair wouldn't match, and then we would return false right away. If we could pull this off, that would be great because we wouldn't have to copy the string, and then we wouldn't need any extra space. Let's try and implement this approach. I'll model the outermost unexamined pair with a left and right index. So L will start off at 0, and then R will be length of S minus 1. And then we want to keep looking at L and R as long as L is still to the left of R. So while L is less than R, and then if the character at L is not alphanumeric, then we want to skip forward. So while not S of L is alphanumeric, and I'm using the built-in method this time, then we'll increment L by 1. So L plus equals 1. And then we have to be really careful here because at the extreme, if we don't find an alphanumeric character, L will end up being the same as the length of S. And because of that, we'll have to add a check that L is less than length S so we don't index off the array here. So let me add that check. L is less than length S, and then I'll combine it with what we had before. And then we have a really similar situation with R. So while SR is not alphanumeric, we want to move it to the left. So while not SR is alphanumeric, then we want to decrement R, which will move it to the left. And then we have to be really careful again, because if we don't find an alphanumeric character, then R will end up being -1, in which case we would index off the array right here. So let me add a check that R needs to be greater than or equal to 0, and then I'll combine it with what we had before. So at this point, left and right could have met or crossed, in which case there's nothing left to process. So I'll add an if L is less than R to make sure there's still something left to check. So if L less than R, and then if the pair does not match, we can immediately return false. So if SL not equal to SR, and then I'm going to lowercase both of them so we normalize for case. So dot lower. And if they don't match, we return false. Else, if they do match, we can move L and R towards the center so we can look for the next unexamined pair if there is one. And if after doing all that, we don't find a mismatched pair, we can return true. And if we submit, we can see that this works. And finally, in terms of performance, the time is going to take O of n because we're looking at each character just one time. And then for space, it'll be O of 1 because we're not copying anything this time.